Class, welcome to exercise 60, which is about the last theory of this chapter, theory B from paragraph 8.5, from volume to scale factor. They give us two balls. Ball 2 is an enlargement of ball 1, so this is the image, this is the object. Calculate the scale factor, that's what they state. Okay, they don't give us any dimensions, they don't give us areas, they only give us capacity. Volume 1.6 liter here and 2.4 here. So I can now find k to the third, k cubed. How can I find that one? Yeah, by dividing the volume of the image. Let's make this a bit fancy. And divide it by the volume of the object. The image is the new one, 1.6. Object is the old one, 2.4. Right? And this has to be k to the third because we're dividing volumes. So you don't get, for example, k in one go this way. And if you divide those, that gives us the very nice number of 0.667, etc. Or 203, close to say. What's going to be my scale factor? Well, I want to go from k cubed to k, and this is the new trick that we have been introduced. If we take the cube roots of k to the third, we find k. This is k to the third, so I take the cube roots of 0.667, etc. And let's punch that into our calculator, shall we? Let's see. 203. And I don't know why he is taking answer here. Don't want. Oh, this. I have a different calculator than I normally use here. I have to type it in like this. Okay, that works. Okay, 3, and then this, and then 2 divided by 3. So my scale factor is approximately, because they want us to round again, 0.1 decimal place only. Okay, then it's 9. 0.9. Okay. So from k to the third to k, you take the cube root. At B, the area of the base of the ball of 1 is 141.3 squared centimeters. Calculate the area of the new one. Area. For area, we have to use k squared. So the area of the image, the new thing, is k squared times the area of the object. We know k, we just calculated that, 0.9 approximately, times the area of the object, 141.3. And if you're now going to calculate this, 141.3, you will find around to 1 decimal place 107.8 watt squared centimeters. I didn't use 0.9 right now. I used a number that originally is right here without rounding it off. Let's see, do I get a different result when I use 0.9? Or does that give me? Yeah, it gives me a different result, but does it matter when? Oh, that gives me quite a difference. I'm curious to see what your answer book gives you, because if you use this number right here, then you actually find 114.5. And they let us round at A. But if you use the original number, that is here, that was not 0.9, that was, oh, now I've done and lost it right here. Let's see, it was the cube roots of cube root of 2 divided by 3. That was 0.87358, etc. If you use that instead of 0.9, you find approximately 107.8. And if you use 0.9, you find this one. Maybe I can check it in a moment. Let's just check it, and that will be the end of this video as well. Maybe, do I have it opened right here? Yes, I have. Let's check. Exercise 61. Let's put in for a moment. 61. Oh, it's not 61, it's 60, sorry. Did I write 61 here? Oh no, 60. I'm just imagining things. Yeah, they say 107.8. So they let you round off at A to 0.9. And then they say, yeah, well, that's fine and all, but still have to use the non-rounded number here, just as I did. So you find 107.8. And I think this is more correct than this one. I think this one is a bit sort of correct. I always try to not round off, only round off in the end. And here you round off here, and then you round off here again. And then you see in the end that can really give you a big difference. Maybe you have calculated this 114.5 and you check the answer book and you say, well, that's completely wrong. What have I done wrong? Yeah, you just used a rounded off number, right? So be on the lookout. Always try to only round off in the end. Okay, good luck.